Okay, so right here, what I want to do is I want to identify the time intervals for all the different shapes. So I have a triangle from 0 to 2 seconds. So I just want to identify that the first time interval is 0 to 2 seconds. The next shape is a rectangle from 2 to 3 seconds. So that's my next time interval. After that, from 3 to 7 seconds is going to be a triangle. 7 is where it crosses the x-axis, and it goes from having positive displacement to negative displacement. So I'm just going to repeat that process, identifying all the shapes. This next section from 9 to 11 seconds has two shapes that I have to identify. It has this triangle right here, and then it has a rectangle here. Okay. Now, the triangle, I have to identify the triangle's base, which is from 9 to 11 seconds. So the base is 2 seconds. But then I have to identify the height of just the triangle part. Now, the height of the triangle goes from -2 meters per second to -3 meters per second. So that's what I'm going to want to use when I go to calculate the area of that triangle. Now that I've identified all the time intervals and all the different shapes, I'm just going to go ahead and calculate all the different individual areas. So that first interval is a triangle, so that's 1/2 a base of 2 times a height of 4. So 2 seconds times 4 meters per second, and I end up with a 4-meter displacement. I'm going to repeat that for all the different shapes until I have answers for all the different areas. Now, if I have a shape that's under the x-axis, that's going to be a negative displacement. Because this section from 9 to 11 seconds has two different shapes, I have to do two different area calculations and then add them together. So first is the triangle from 9 to 11, which has, again, the base of 2 seconds and a height of -1 meter per second, right? -2 meters per second to -3 meters per second is a height of -1 meter per second. Okay, so what I've done here is I have two columns that have all my area calculations, which in black, I have the negative signs for the negative displacements. And I'm just going to total it up, and this will give me my total displacement and final position. So when I add this column together, I am going to take into account the negative signs. In red, I'm just going to total all the values, right? So in the red column, I'm going to ignore the negative signs, and I'm just going to total up all the different motions. What this is going to give me is the total distance traveled by this object. So for the displacement, I end up with 21.5 meters. But when I do the distance traveled, we're going to end up with 52 meters.